will continue with the slides, but before that, let me remind you something about combinations. I don't know if you remember them from high school or discrete mathematics. Combination says that how we can combine the choices that we have. And if we have n is the total number of samples, and k is the total number of different way of choosing. So the number of combination is n factorial divided by n factorial multiplied by n minus k factorial, right? And we were showing it by that. For instance, if we toss a coin 10 times, the total number of combination of 7 head is, the question says that how can I have 7 head if I am tossing a coin 10 times? It will be 10, 7, a combination of 10 and 7, and this is 10 factorial divided by, no, this is k factorial. You're sleeping. 7 factorial divided by 10 minus 7, which is 3 factorial. And we can write it as seven factorials will cancel each other. This is 3, this is 4, and 120 is the total way of making this combination. Now, the reason that I put this, I talk about this is a bit later we want to solve an example. And inside this example, we have to remember how we can do these combinations. But before I go to the slide, let me ask another question. What is the probability? We have a fair coin. What is the probability of having head? What is the probability of having head? Probability of head is 1 over 2. Probability of 2 heads is 1 over 4. Probability of 3 heads, if we toss a coin, is which is 1 over 2 to power 3. This is 1 over 2 to power 2. So probability of n head is 1 over 2 to power n. What is the probability? So the question is this. What is the probability of having 7 heads in tossing a coin 10 times. I want to toss a coin 10 times. How do I do it? The probability is probability of head if I am tossing it 10 times multiply by number of having 7 heads. This is how we calculate it. So it will be 1 over 2 to the power 10 multiplied by 10 to the 7. It is 120 divided by 2 to the power 10. What is 2 to the power 10 if you have a calculator? There's one. And 120 divided by that. 0.017. Okay, so keeping this one in your mind, we will do an example a bit later when we are talking about the joint probabilities. You're right. Now, if you remember, the last thing that we taught on last session was about the cumulative distribution function. And we said this cumulative distribution function has very important properties. We use it a lot. Actually, in the image processing course today or on Wednesday, you will see that we will use this cumulative distribution function. So you will see an application of this one in order to enhance the illumination of the image. But some of those important properties was it is not decreasing, it's a non-decreasing function. Why? Because probability is either 0 or positive. And as the CDF was saying that we are always adding the probabilities, so it means that either the probability will be the same because we are adding the 0 probability, or we are adding a positive probability, which means that it will be increased. Probability cannot be negative. In other words, CDF cannot decrease. The other two important thing is that at infinity, the CDF is 0 minus infinity, and at the plus infinity, the CDF is 1, because we know the addition of all the probabilities will be 1, cannot be more than 1. Now, we talk about discrete random variance, discrete probability distribution function, we call them probability mass functions. Now let's look at the continuous form. And one of the most important, most famous distribution functions that we have is the uniform distribution function. If you remember, we gave the example of a die before, or just a minute ago, we did the example of the coin, and we said this is a fair coin, which means that the probability of all the events are equal to each other. In other words, we have a uniform distribution in there. But we can have this event to be, let's say, in continuous form. And if it is in the continuous form, this is a constant line, as you can see, parallel to the x-axis. If the length is a, the height will be 1 over a. Why? Why? If the length is a, why the height is 1 over a, Alex?
So that the probability will be 1.
Because the area underneath the graph is CDF, is the summation of all the probabilities. And as the summation of all the probability is 1, so we know that the area underneath this graph is an area of a rectangle. So it should be the height multiplied by the width. So it should be a multiplied by 1 over a in order to make it 1. The next famous one is something which we call it a Gaussian or normal distribution. Now, Gaussian or normal distribution, which is also known as a bell-shaped distribution because it looks like a bell, or they call it a hat distribution, it looks like a hat. This distribution is very important because in the reality, this is one of the distributions that we can see a lot. We have a theorem which we will talk about it, it's called central limit theorem, and it says that if we have infinitely many different types of distribution and we add them, this is the result of their addition. So this is a very good distribution. In many applications that we have in computer science, this is a nice distribution because if you convert this distribution into the frequency domain, you will still get the same distribution. Of course, the parameters change, but the Gaussian distribution in time domain will be the same, will be a Gaussian distribution in the frequency domain. So, this is very useful because of that. Of course, we want to calculate about the probability, and we remember in the continuous form, the probability was calculated in this form. The probability of x less than x, lower x less than x, is integral from minus infinity till x of, right? This was the way that we were defining it. In other words, if this is my distribution, and this is the value of x, this area is probability of x is less than capital, that's what we call like capital X. So this is how we were defining it. And if between these two green borders, it is the probability of x is between A and B. Now, we have to calculate this integral. And what is this function? What is this function of f? Is this. Calculation of this one, I'm not saying that it is very difficult, but it's not very easy. But the good thing about the normal distribution, the Gaussian distribution, is that lots of mathematicians already have calculated it, as you may remember and know it, and we have the table of the normal distribution. In other words, we can look at the table and we can calculate what is the area underneath the graph. We will review later in this course how you can look at the table in order to find the values. Is there anyone who has never used this table before? Do you all remember? Do you remember how to use the table? We will review it anyway. We will review it. There is no problem of that. But the good thing, as I said, about this distribution is that that table exists there. And it also has a symmetry, and we can benefit a lot from that symmetry. And the reality, we see this distribution a lot. Another famous distribution is exponential distribution. And as you can see, it is an exponential function. And we write it in this form. When x is greater than 0, we have it as a lambda e to the power minus lambda x, and we assume that lambda is a positive number. And when x is less than 0, it is 0. Why lambda cannot be a negative number? Why lambda? Here I say that lambda is a positive number. Why lambda cannot be a negative number? For example, why lambda cannot be minus 1?
The probability is not less than 0?
Because the probability cannot be less than 0. If lambda is a negative number, for example, minus 1, e to power x, you know that x is greater than 1, e to power a function, a value is always positive, so multiply by a minus, it means that the value of the probability is negative. Already we know that also it will become an unbounded function, in other words, it will start to go to infinity. And we know the area under this graph should be 1. Now, let's do a few tests. We have an experiment, and within this experiment for the random variables 10, 11, 12, 13, and 14, we have got these probability values. And can you tell me that what is the probability? This is a discrete random variable. What is the probability of x is equal to 9? Probability of x is less than 10. Probability of x is equal to 15. And probability of x is greater than 14. Now, the good thing about discrete random variables, if you remember, was we don't have integral, we have summation, we can always add the numbers. Now, tell me, what is the probability of x is equal to 9? 0. Why it is 0? Because if you add these numbers, you see that the summation is 1. In other words, any value less than, if the random variable is less than 10 or greater than 15, its probability is 0. It cannot be any other number because already the summation is 1. So, in other words, the probability exists for the events of x is 10, 11, 12, and 13, and 14. So, if x is 9, it will be 0. If x is less than 10, what does it mean? It means add the probability from minus infinity till 10. 10 is not included. So what is the result? 0. Because everything is 0. What about the probability of x is equal to 15? It is 0 because we don't have any value for it. What about probability of x is greater than 14? X is greater than 14 means that we start with probability of x is 15 plus 16 plus 17 and so on. And we know that starting from 15 till plus infinity we are 0. What about probability of x is less than 17? 1. Because it means the addition from minus infinity till 16. We know that from minus infinity till 10, before 10 to 9, it is 0. From 10 till 40 we have values, we add it. 15 and 16 is also 0, and the addition of this one is 1. PMF of this function. Can you draw the PMF? How does the PMF look like? We write here, let's say 9, 10, 11, 12, 13, 14, 15. These are zeros, and anything above or below those are 0. 10 is 0.4. 11 is 0.2. This is also 0.2. These are 0.1. So this is the PMF. So the number of patients seeing a doctor in any given hour is a random variable and it's represented by x. The probability of the distribution of the x is also given. So if it is 7 o'clock, the probability of a patient seeing a doctor is 0.4, and so on. The question is this: find the probability that in a given hour exactly 14 patients arrive. Sorry, it's not the hour, it's the number of patients. If 10 patients wants to visit, the probability is 0.4. If 12 patients are visiting, it's 0.2. If 14 patients are visiting, it's 0.1. So the question is that what is the probability that 14 patients will be coming to the hospital and visited by a doctor? What is it? 0.1. What is, so this is an exact value. You will look at what is the probability of x is equal to 14. Now, let's translate this one. At least 12 patients will be arrived. In other words, what is the probability of x is less than or equal to 12? It means start from minus infinity, add all the values to 12. We know from minus infinity to 9 to 0. We have to add the probability of 10, 11, and 12. 10, 11, and 12. If you add it, what is the value?
0.8.
So, probability of x is less than or equal to 12. What does it mean?
0.
No. What is the meaning of this? What is the meaning of this one? What is the difference in between these two? Px is less than or equal to 12 and P of x greater or equal than 12. Honest, what is the meaning of the first one?
Less than
12. What does it mean? If you want to write a sentence, what does this sentence is?
x is less or equal
Morteza?
at most.
So this is, what is the probability that at most, maximum 12 people are visiting? What about this one? At least 12 people are visiting. So this time we have to consider what's the probability that at least 12, 13, because 13, if you have 13 patients, it means definitely you have 12 patients, and 14, because if you have 14 patients, it means that definitely you have also 12 patients. So which one do we have to calculate in part B? The second one. Probability of x is greater than 12, which means that probability of 12 plus probability of 13 plus probability of 14 plus probability of the rest, which is 0. So it will be 0.2 plus 0.1 plus 0.1, so it will be 0.4. What about at most 11 patients? Then it means that the probability of x is less than or equal to 11. So take care of the word at least and at most. At most means that it can be 9, 10, maximum 11. So the rest, everything below 10 is 0, so it will be 0.4 plus 0.2, which is 0.6. Now, another question. If you toss a die, so a die, what is the probability of each of its faces? 1/6. What is the probability that you roll a 3 or less? What are the outcomes if you have a die? What are the outcomes? 1, 2, 3, 4, 5, 6. So n of omega is 6. The question says the number that I want to see is 3 or less than 3, which means that 3, 2, or 1. So what is the number of elements in my event? 3. So the probability of this event is 1/2. Now, we do it twice, or we have 2 dice in our hand and we roll it. And the sum of the face value is 6. What is the probability? Now, if we have 2 dice, what are the total number of samples that we have? You know, for 1 die we have 1, 2, 3, 4, 5, 6, right? This is for 1 die. If I have 1 and I dagger the next one, I have another 6. If it is 2, I have another 6. And if I continue like this, you will see that I have 6 multiplied by 6, which is 36 samples. So this is n omega, 36. Now the question says the summation of the numbers that I have, is what? The sum of the values is 6. So the sum of the values are 6. What are the values? Can you tell me? 1 and 5. 5 and 1. 2 and 4. 4 and 2. And 3 and 3. Right? Do you all agree? I have a die and I have 2 dice and I have to roll them. And it says that the sum of the face values is 6. What are the situations? These are the ones that the sum of the faces are 6. So having 6 is not good because definitely the other one will be a value and the summation is not 6. So these are the values that we have. Question says, what is the probability that at least one of the dice come of 3? In other words, tell me how many of these ones has number 3? Only 1. So here in this question, n omega is 1, 2, 3, 4, 5, and the number of events that we have is 1. The number of events that we have is 1. So what is the probability? 1/5. Because we know we can have only these numbers. And only one of them has the number 3. Now, up to now, one random variable, the number of patients which are visiting the hospital, or we have a die and the summation is something. So we have only one random variable. What will happen that in the question we have more than one random variable? For instance, I want to roll a die. So this is one random variable, and the weather is sunny. And this is another random variable. And you can define it in a way that these two can come together. So what will happen if we have more than one random variable when we are defining the question? So we are talking about something which is called a joint probability distribution. In other words, we have more than one random variable. Now, you can understand from the example that I gave you, rolling a die, and let's say have number 6, and having the weather to be sunny are not correlated with each other. In other words, you can roll a die and you get 6 and the weather can be sunny. You can do it and you get the 6 and the weather can be rainy. So sometimes the random variables that are joined together, they are independent. We put them into one system, but they don't have any relation to each other. So it is good because we can do some calculation much easier. But sometimes they are very much inside each other and they are depending on each other. In other words, we cannot separate them easily. But if a random variable that we have, if an event that we have has two random variables, we say that it has a joint probability distribution function, and we show it by f index of x and y. If you notice in the previous formulations, we had only one variable function, and we call it fx. And now we have a function which has two random variables. So we use this notation now. Fx of x, f x and y of x and y. And in our book, what we do, we are using this one with the capital F. And we use the lower f or the lowercase if we want to talk about a distribution function of one single random variable. So when we are using it, we put the index of x and y. It means that this is the random variable of the joint distribution function. For simplicity, we don't write this part. So I write f of x and y, and you understand that it is a function of a multi-distributed function, or joint distribution function. Now, how can we interpret it? The interpretation is this one. F of x and y, it means that the probability that x has some condition and y also has some condition. So what is the probability of having a number greater than 5 and the weather is sunny? So there are two conditions that we have to check. And when it comes into the matter of description of this function, it will be a double integral, of course. If you remember, previously we were saying that we have this f of x, and it means the probability of x is less than equal to x, and we were representing as minus infinity till x of f dx, right? Now, we have two conditions because they are joined. So instead of x, we have x and y, and we are defining a new condition. So it means that this needs to be also added. This needs to be also added. Now, here we do an example. Of course, I have talked about only 2 joint random variables. We can have 3 joint random variables, 10 joint random variables. Now here, look what we have. We have a question, and the question says, in a rolling fair dice experiment, represented outcomes are 3 big digit numbers. So we have a number which is a 3-bit. We know that if we want to represent number 1 to 6, we already need 3 bits. So we have 1, 2, 3, 4, 5, 6. And with 3 bits, 1 is represented like this, 2 is represented like that, and so on. Now we define the f of x and y to be in this form. X is 0, y is 0. What is the probability of having x 0 and y 0? Again, everything will be back to the main definition of the probability. What is the definition of probability of event E? Number of event E divided by total number of the samples. So the same thing also is valid here. It doesn't matter if you have a double integral or double summation. The event says that we have x to be 0, y to be 0. Let's look at the outcomes. How many times we have x 0, y 0? Only 1. What are the total number of events that we have? 6. 1, 2, 3, 4, 5, 6. So it is 1 over 6. Now, x is 0, y is 1. Let's see how many times we have x 0 and y is 1. X 0, y is 1, 1. X 0, y is 1, 2. So we have 2 of this outcome. 2 over how many outcomes? What is the total number of the outcomes that we have? 6. 2 over 6 is 1 over 3. Similar thing for 1 and 0, and 1 and 1. And otherwise 0, which is an impossible case. Now, why we need to talk about this joint probability? Because as I said, in the reality, when we have an event, it doesn't simply depend on one random variable. It usually depends on many more random variables. But these random variables sometimes behave in a very good way. In other words, they are independent from each other. Assume that we have f of x and y, and x and y are independent from each other. I will show an example in a second. But it means that if we have a function like this, we don't need to use the double integral to find the values. We can simply, we know what is the probability of x, we know what is the probability of y, we multiply them. Before I go to the next line, let's show it in an example. Assume we have weather to be weather can be sunny, cloudy, and rainy, and a die is 1, 2, 3, 4, 5, 6. And the question is this: what is the probability of rolling a die and get a prime number when the weather is raining? What is the probability of rolling a die, get a prime number, when the weather is raining? Now, first question. Is there any correlation between rolling a die and the weather? No. So it means that they are independent. They are independent. So what we have, f of x and y is this. Probability of x is prime and y is raining. We know that because they are independent, I only need to calculate What is the probability of having a prime number multiplied by what is the probability of the weather to be rainy? What is the probability of having a prime number? What are the prime numbers? 2, 3, 5. So 3 over 6, which is 1 over 2. What is the probability of having rain? 1 over 3. So what is the probability of having a prime number in rainy weather? Is 1 over 6. Now, when events are independent, it also implies that probability of x intersected by y is probability of x multiplied by probability of y. So if x and y are independent, what is the total number of elements? Can I say that if x and y are independent, the total number of elements which are in x and in y at the same time is 0? X and y are independent. Okay? I draw a Venn diagram. This is x, this is y. And we know x and y are independent. The question is that, can I generalize and say that the number of elements of x intersected by y is 0? Because x and y are independent. Yes? No? On some condition, yes. Some condition, no. In other words, from independency, can I conclude that if the variables are independent, it means that they are also disjoint? Because n, x, and y is equal to 0, it means they are disjoint. They are not intersecting to each other. They are different from each other.
No? Like if we have two dice, then they both will have.
I think the joint probability exists is not 0, but it just can be obtained by multiplying.
Yes or no? I mean, it's not true. When the variables are independent, it doesn't mean that they cannot happen at the same time. In other words, they're being disjoint, having the intersection 0, it means that they cannot happen at the same time. When they are independent, we don't say that they cannot happen at the same time. What it means that happening of one is not balancing the happening of or not happening of the other one. Similar to this example. Having a prime number, if I die and the prime number comes, suddenly the weather will not change into the rainy weather. Right? Or if the weather is sunny and I would die, it will not affect in order not to have a prime number. But can I die and I get number 5, which is a prime number, and the weather is raining? Yes. In other words, their existence of one is not affecting or enlarging the existence of the other one. We can show an example that they can be independent and they can be disjoint, but in general we cannot say that if the random variables are independent, they are also disjoint. So, if they are independent, however, we can say that the probability of x intersected by y is probability of x multiplied by probability of y, which already this example is representing it. Because in the discrete form, in this example that I taught, actually I'm talking about what is the probability of intersection of having a prime number and a rainy weather. which is the multiplication of both of them. So this is a very important thing. Independency does not imply that they are disjoint. In other words, they are mutually exclusive. It doesn't conclude that. Now, I have a disjoint function, f of x and y, right? I have f of x and y. I know that if they are independent, it's a multiplication of f of x and f of y. But the question is, in an event, in a joint event, I have f of x and y, but I want to know what is only f of x, or what is only f of y. In other words, I want to know what is the distribution function of x, and what is the distribution function of y. Although I have the distribution function of both of them at the same time, in order to find each of the density function of distribution functions, what I do, I will use an integral. If I want to find, look, what I have in my hand is f of x and y. And what I want to get is f of x. Which variable do I have to keep, Nastya? I have f of x and y, and I want to get f of x. Which random variable do I have to keep? Y. I have to keep y. So how do I keep it? By integraling on y from minus infinity to plus infinity. So this will result into getting an fx. Oh, I'm showing you a continuous, and the formula here shows you a continuous random variable. What about the discrete one? Over y from minus infinity to infinity of f of x and y. So if you want to get f of x, you integrate f of x and y over y. And similarly, if you want to get f of y, you can integrate over x of f of x and y, which means that you are removing the x, and what is left is f of y. And similarly, if you want to do it for a discrete form, you have to use the summation. Now, another important aspect in the probability, still we are revising the probability, another important aspect is the Bayesian rule. And it's called the conditional distribution function. What we mean by conditional distribution function is this. What will be the probability of an event if something else has happened? What is the probability of having something given some other things has already been happened? And this is called the Bayes rules. And in computer science, most of the examples that we have is kind of a conditional probability. What is the probability of having an error if we have this type of noise inside the channel? So we are always having some condition that we are adding. And in probability, it is known as Bayes rule. And the Bayesian rule is described in this form, but it actually comes from how we are defining the conditional probability. Now, let's read this formula. What is the probability of having event X if event Y has happened? Or what is the probability of X given Y? In other words, Y has to be happened first, and we want to calculate the probability of X. Look, this is not calculation of probability of X. This is not probability of X. This is probability of X if Y has happened. So let's do in this form. If X and Y are independent, if X and Y are independent. Okay, focus here. X and Y are independent. What does it mean, X and Y are independent? Ask her, what does it mean, X and Y are independent? Yes, probably was correct, but in a sentence, what if I say that this right is independent from left, what does it mean?
If one happens, it doesn't affect the other one.
Yeah, occurrence of one is independent from the other one. So, right and left are independent, which means that right can happen, we don't care about left. Left can happen, not happen, still right will happen. So what is the probability of having right if Y is happening? Will it be affected by happening of Y? No, because it's independent. So probability of, if X and Y are independent, probability of having X given Y is independent from Y. So if X and Y are independent, what is the probability of X given Y? What is it? Probability of X. Why? Because we just described it philosophically. X will happen independent from Y. So what is the probability of having X given Y? When X will happen, doesn't matter if Y is happening or not, so it's probability of X. So this is the philosophy behind it. But of course, mathematically we can prove it. How? The condition of probability says this is the probability of X intersected by Y divided by Py. Because X and Y are independent, in the previous slide we said that this is P of X multiplied by P of Y divided by P of Y. So it will be P of X. So this is how mathematically we can prove it. If X and Y are independent, probability of X given Y what is, as you know, is probability of X. But if they are not independent, then probability will be calculated by using this formula. Did you understand about this independency? You know, before we prove it, we have to be able to feel why probability of X given Y is X. Did you understand it? Did you feel it?
Yes.
Okay. Now, I'm not talking about independence now. And I'm telling you that X and Y are disjoint. In other words, if X happens, Y cannot happen. And if Y happens, X cannot be happen. Like probability of having even number or odd number. We cannot have a number which is even or not. It's either odd or even. Okay? Now, if X and Y are disjoint, what is the probability of having X if Y has happened? Zero. Because they cannot happen at the same time. So probability of X if Y has happened, because Y happened, X will not happen zero. So if they are disjoint, if X and Y are disjoint, which means that X intersected Y is empty, probability of X given Y is probability of X intersected by Y divided by probability of Y. Because this is empty, we know that this is 0 divided by probability of Y, and this is 0. This is how mathematically we prove it. But we can understand it that if they are disjoint, X given Y cannot happen, because if Y is happening, X will not happen. Now, let's look at this. The condition of probability in general is given in this form. the probability of x intersected by y is probability of x given y multiplied by probability of y. Do we all agree? Now, assume that I have the green and the blue sets, and here the heads are intersecting, okay? Can I say that the intersection of green and black is the same as intersection of black and green? Yes. It doesn't matter if you look at it from here or here. The intersection is not being changed, right? In other words, x intersected by y is equal to y intersected by x. Now what I do is this. I switch the value of y and x. So it will be y given x multiplied by p of x. But because x intersected by y is equal to y intersected by x, so this means that these two are equal to each other, right? Left hands are equal to each other, so right hand should be equal to each other. So it means probability of x given y multiplied by probability of y is equal to probability of y given x multiplied by probability of x. What I have done, this is the definition of the conditional probability from here. What I am doing, I'm just changing the location of x and y. So I have to do it. All the x will be y, all the y will be x. And I have the probability of x intersected y. Here I have the probability of y intersected by x. And I know that they are the same. So it means the right hands will be the same. So I write in this form. So what is the probability of x given y? I divide probability of y given x multiplied by probability of x divided by probability of y. So I can calculate this value. So, and this formula is called the Bayesian rule. The Bayesian rule, it says that sometimes calculation of probability of x given y is not easy. Whereas the probability of calculation of probability of y given x is easy. Either it's given in the question or it's easy to calculate it. It's easy to calculate it. So we can always replace it. How we can get to this formula is from the conditional probability. So by using these steps, you can actually prove the Bayes rules. And we did solve several examples regarding to this one. Let's do even one example. And after that, I will stop the projector and I will solve two more examples regarding to this previous example that I solved it on the board at the beginning of the class. Now, the question is this. In rolling a fair die, if x is the outcome of having an even number, so x is outcome of having an even number, and y is the outcome of having a prime number. X is even number, y is prime number. What is x intersected by y? 2. Right? The question is, what is the probability of occurrence of an even number if a number is prime? So you have to learn how to read it, because usually what happens in a question, in a problem, we have this sentence. We have to interpret the sentence into this form, because if you know you have to calculate probability x given y, then the rest is just substituting numbers. So we have to understand how to read this sentence, this English sentence, into the mathematical form, how to translate it. So the question is this: find the probability of occurrence of an even number, probability of occurrence of an even number, if the number we know is prime, given that the number is also prime. So, which condition is given? Even number or a prime number? Which one is an obligation? It must happen. And which one is the probability that we want to calculate? Which one has happened? Which one is an obligation? Even number or prime number? Prime number. If it is prime number, it's an obligation. Find the probability of even number. So it's probability of x given y. And then we can easily use this probability of x intersected by y divided by probability of y. What is the probability of x intersected by y? Is 1 over 6. Probability of y is 3 over 6, which is 1 over 2. So it will be 2 over 6 or 1 over 3. Now, question. Are x and y independent? In other words, having an even number and having a prime number, are they independent? How can I find out if they are independent or not? There are several easy ways. If x and y are independent, it means that probability of x given y is equal to px. What is px? 1 over 2. Is 1 over 3 equal to 1 over 2? No, so they are not independent. Or, if they are independent, probability of x intersected by y is probability of x multiplied by probability of y. What is this? 1 over 6. What is probability of x? 1 over 2. What is probability of y? 1 over 2. 1 over 2 multiplied by 1 over 2 is 1 over 4. It's not equal to 1 over 6. So this is a way that we can test. We already have thought and proved that the probability of x given y is equal to probability of x if they are independent. You already know the why. Because happening of x doesn't need to y to be happening. Now, I want to solve a few examples on the board. So I will stop in here. And I will solve a few questions on the board. So let's put this form. I write them down and I want you to try to solve it. And then I will solve it. But in order to solve it, we need to remember these combinations. We need to remember these combinations. Do you have any question about this example? So we know how to calculate the probabilities, the combinations. So let's do a couple of examples. Only a few slides left in order to finish the revision of the elementary probability. And after that, we will start talking about marginal probabilities and so on. So we will use more frequently. example. Toss a coin 10 times. If you know that exactly 7 heads are tossed, what is the probability that your first toss is head? So I have a coin, I'm tossing a coin 10 times. Exactly 7 times I have head. The question is, what is the probability that this exactly 7 times head is happening if the first one is head? And part B, that at least 7 heads are tossed, then what is the probability that your first toss is head? Now, in the part B, I'm not talking about the exact 7 times. I say that at least 7 times is head. What does it mean at least 7 times is head? What are the possibilities?
7, 8, 9, 10.
Yes, because we are tossing 10 times, so it can be like 7 times head, 8 times head, 9 times head, and 10 times head. So, can you see that this is a conditional probability? Can you see it? It's conditional probability because we have conditions. So, it is important to find out what is X, what is Y. We are talking about part A. Tell me what is X and what is Y, because we want to calculate probability of X given Y. What is X and what is Y? What is it?
X will be the first head.
Yes. First toss is head. Y is, in part A, exactly 7 head. So the question is that find the probability of first toss is head, given that exactly we have 7 heads. So, what is the probability of Y? At the beginning of the class we solved it. What is the probability of having 7 head? 10, combination of 10 and 7 multiplied by 1 over 2 to the power 10. This is so the challenge here is to find is to find x intersected by y. In other words, the probability of that one. Or if you find the combination of the numbers that we have x and y. Okay, guys, maybe you look at me for a second, and I will let you do the part B. Do you have any question about this? Now, I want to find out what is the intersection of x and y. Now, let's translate the intersection of x and y in English. What does it mean? It means those combination of 7 heads, that the first one is head, because we can have 7 head in this form. Tail, 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 the rest head, right? We can have tail, head, tail, tail. In other words, the first one is not head. So, what does this mean? This means that those 7 heads whose first is head. In other words, x intersected by y is, I have 2 locations. Look, I already have 7 locations which has to be head, but I will put it this. First location and second to 6th location, so 7th location. 7th location, which means that 6 locations, right? Because I have 7 locations for the head. Already, I want to have exactly 7 heads. It means that I have 7 locations. But I know the first one is head. Can you tell me that how many choices do I have here?
2.
Why 2? But I want the first one to be head. So how many choices do I have? 1. The first one must be head. So I have only 1 choice. Multiply by, now I have 6 choices. I have 6 choices. Out of how many? 9. Because I'm tossing it 10 times, right? The first one is already head, no choice. How many left? 9. And the 6th location I have to fill it. One multiplied by combination of 9 and 6 is the combination of 9 and 6. And what is the probability? I have to multiply this one by 1 over 2 to the power 10. So, probability of x intersection y is 9. 6 multiplied by 1 over 2 to the power 10. How did we get 9 over 6? The first one is head. I don't have any alternative. Multiplied by, now one of the choices already head. So how many left? 9. How many heads should I have? 6. Why 6? Because the total is 7. The total is 7. The first one is already head. 6 out of the 9 should be head in order to make the exactly 7 heads. So this is the Px intersected by y. So for part A, I need to calculate Px given y, which is P of x intersected by y divided by P of y. which is 9, 6 multiplied by 1 over 2 to the power 10 divided by 10, 7 multiplied 1 over 2 to the power 10, and the result will be 7 over 10. 7 over 10. We have calculated it that probability of exactly having 7 head was 0.11, but probability of having 7 head, given that the first one is head, is 0.7. Do we have any question about this part? Did you understand how we are calculating the values on us? Did you understand how we are calculating the values? What is that? Yeah. Nasta, did you understand it? Now, part B. Okay, part B, X is given the same. The first toss is head, but Y is changing, it's nothing. What is Y this time? At least 7 head. Can you tell me what is the meaning of at least 7 head? How many heads can I have? I can have 7 heads, 8 heads, 9 heads, and 10 heads. So, what is the probability of Y? Probability of Y is how many Y's do I have? How many Y's do I have? In other words, what is the number of Y? Previously, when I had exactly 7 is this. 10 and 7, right? This means exactly 7. Right? Now, but it says that at least 7 means exactly 7, or exactly 8, or exactly 9, or exactly 10. What is the meaning of 4? Summation. So it is this plus 10 combination of 10 and 8, plus combination of 10 and 9, plus combination of 10 and 10. So, if I want to know what is the probability of Y, look guys, if I want to see what is the probability of Y, all these summations multiply by 1 over 2 to the power 10. So this is the probability of Y. Now, what I have to do, I have to find the intersection of X and Y. It is, again, we have to develop the idea based on the previous part. So what is the meaning of X intersected by Y is those of 7 heads whose first is H, but we know that we have at least 7, so it can be or those of 8 heads first is head, or those of 9 heads whose first is head, or those of 10 heads whose first is head. Whose first is head. We know that what was this one? 1 multiplied by 9, 6. This is 1 multiplied by 9, 7. This is 1 multiplied by 9, 8. This is 1 multiplied by 9 by 9. Can you tell me that? Because this one was easy to guess. How many of 10 heads do we have that the first one is head? 1. 9 given 9 is 1, right? You know, 9 combination of 9 is 9 factorial divided by 9 factorial multiplied by 0 factorial. These are cancelling each other, so 1 divided by 0 factorial. What is 0 factorial? 1. 0 factorial, you know, 1 factorial is 1, 0 factorial is also 1, so the result is already 1. So, probability of x intersected by y is 9, 6, 9, 7, 9, 8, 9, 9, multiplied by 1 over 2 to the power 10. So probability of x given y is the probability of x intersected by y divided by probability of y. 1 over 2 to the power 10s will cancel each other. So what is left is 9, 6 plus 9, 7 plus 9, 8 plus 9, 9 divided by 10, 7, 10, 8, 10, 9, and 10, 10. And if you calculate it, the result will be 0.73. 0.73. 0.74. What was the answer of part A? What was the answer of part A? 0.7, right? Now we are enlarging the sets of the occurrence. So we are expecting to see this number to be greater than 0.7. If the number you calculate is less than 0.7, it means you made a mistake. Why? Because this one, exactly 7 was part A, and now I'm adding some other parts. So the result must be greater than 0.7, because we know that they are not zero probabilities. They are small, but they are not zero probabilities. Do you have any question? If you have no question, this is the end of the lecture for today, and I will see you all tomorrow.